Okay, today is December the 11th, 2021, and right now the 2021, and right now at 10:30 p.m. we have a temperature of 42 degrees here in the foothills of Los Angeles. The relative humidity is 66%. The dew point is 32 degrees, and we have a barometric pressure of 29.92, or about 1,013 millibar. All right, so the big news is the tornadoes in Kentucky and Tennessee, Illinois, Missouri, and Arkansas. And that was a result of the merging of tropical air right down here. This was allowed to merge with this. This is a surface low all the way up to the 300 millibar level. We'll take a look at the pressure maps, but the weather controllers normally prevent. There's a line of just a black area, which I'll show right now in the water vapor map. It looks like this, and it runs all the way across. You can see right here that they didn't carry that line, that guard band, that electronic fence, I call it, of high pressure. They normally separate and prevent this flow out of the tropics from mixing with these Pacific storms, which are moving like a conveyor belt right across the U.S. So we can see this low pressure develop. There's actually a rectangular imprint in that vortex, which acts to amplify the weather in that vortex. So let's take another look at it and watch what happens. Normally this black area, this guard band, goes all the way across and prevents what we're seeing right here. You see all that tropical moisture is mixing with this much colder low pressure out of the North Pacific, out of the Gulf of Alaska. These are swinging down right out of the Gulf of Alaska. Much colder storm right there. And so this was allowed to happen all year long. If you look at these maps, you'll see this thin area here. It runs all the way across most of the year, but once in a while they let it merge, and we have a lot of tornadoes here. We can see right here. This is being sucked into that frontal system of that storm. Watch it here. Okay, here it is. And we see there's a break there, and now it merges, and we start to really see the development. Let's go ahead and wind this back and kind of do it in slow motion here. We can see the development. So normally we see high pressure all the way across to separate the much colder North Pacific storms with what's going on down here. This is a lot warmer air. This is like a Pineapple Express is coming out of the latitudes of Hawaii. And you can see it merges right there. It starts to merge. You can see it right there. We've got fairly strong flow pattern there, and it just once it starts to merge, that warmer air mass with this, all hell breaks loose. And there was a lot of tornadoes, and the reports I did see on the internet, because I don't watch mainstream television anymore. I watch all the news I get is from the weather reports online and all that. So, but Western Kentucky was really hit hard, and you can see that red all the way through about 5 different states: Illinois, Kentucky, Missouri, Arkansas, and Tennessee. And there was probably other areas too, but 70 people so far as of this morning. That's the last time I watched, or rather heard. I was watching some YouTube videos this morning and saw some of the damage reports. They had a drone flying around in that town in eastern or western Kentucky, and it was a mess. It looked like a tsunami had gone through there. It was total, just catastrophic damage. So if we allow this to play again, we can see that the merging of this system is causing the problem there. And as I say, all year long, the weather controllers, they do a good job of preventing this sort of thing from happening. You see high pressure on the backside. We've got another storm here. Notice they separate the storms with high pressure. This is the next system that's actually coming down right up here. We've got high pressure installed right here. See that clockwise rotation. And this is going to be the next system that's moving into West Coast. This is still a surface to upper level close low right here. And you can see the straight edges, the right angles. There's a rectangular imprint there. You can see it. That acts to amplify the weather system. When they pull that power off, things really get out of hand fast. See that violent development there. Okay. See that big step right there. Right angle. All right, so we have rain scheduled for Southern California on Tuesday, 100% chance. Monday, we have a chance of rain. We'll just see what happens. Now, we had rain on Thursday, the 9th, quarter inch. We should have gotten a lot more rain the previous 3 or 4 days. We didn't get one drop of rain in November. We should have gotten probably about 8 inches of rain in November. We got nothing, zero in Southern California. Even though we had jet stream flow moving in several different times. I made a couple of videos during that time showing that. It happened multiple times. No rain. So we're up to, right now we're up to about 1 3/4 inches of rain. We've got that quarter inch on December 9th. That brings the total for the season up to 1.73, just a hair under 1 3/4 inches. If you look at the East Pacific long wave infrared map, we can see what's happening. This is the jet stream right here, and we see an interruption, a disruption right there. Satellite transmitters evaporating that moisture in the jet stream. Just disappears. This is a high-speed atmospheric river of water, and we see that we have these strange disruptions like we see on the ground with the WSR-88Ds. You've seen I'll show you what's going on right now. But it's similar to that. You have microwave energy or laser energy that just simply evaporates the moisture in the jet stream, much like what we see here going on right here, and I believe it is Fortuna. This is a WSR-88D right now. This is the current Doppler map. There's rain falling in Central and Northern California. Okay, so if we go up to this is the Fortuna location right here, and they have a WSR-88D, and look at the pie-shaped cutouts. They're regulating the amount of rain that that area will get, and they can do it precisely. And so Wall Street is involved in the weather derivatives and weather options. Fresh water is a commodity, and farmers are being driven out of California because they can't get water to run their farms. And so we have criminals running the show, and nothing is being done about it. Nothing is being done about it. Now, in the years that we've had the screwball Newsom and Jerry Brown, we could have built 10 saltwater conversion plants all up and down the coast of California and not worried about this drought at all. We've got, the entire state of California obviously borders the Pacific. Saltwater conversion plants, in fact, the Catalina Island right here, they use a saltwater conversion plant, and that's how the entire island gets its water. San Diego, I believe, is using saltwater. They've got a plant down there. So, there are solutions, but the philosophy of the people that are running this state are not, they're incompetent, and deliberately so. They're trying to ruin the state and the country. All right, let's take a look here. Once again, we have rain scheduled for Tuesday, 100%. All right. Pressure maps. Here we have, this is the surface map currently, and we see the squiggly isobars once again at the surface level. That's the ground-based microwave transmitters, the WSR-88Ds, disrupting the natural flow pattern. And you see these jaggy isobars. You should never see that. They should all be very smooth, but you see out here they're jaggy as well. Now there's a floating platform which I'm going to report on here pretty soon. I've been meaning to do this for many years. One of the other guys that does the weather out, he's discontinued his weather reports, but I think it's the XB1 or something. It's a floating oil platform, it looks like, but it uses a giant phased array radome. It's got several of them actually, but there's one giant one right in the center, and that just floats around, and they can move it wherever they want, and it's very possible that that is what is causing this disruption here in the jet stream. Although there are satellite transmitters that are capable of producing the kind of power. You can fit a 1 million watt iodine laser in the fuselage of a 747. That's already been done. So if they can do that, they can put something like that up in space, no problem, on a satellite. These satellites that are going up now for the DoD and the national NOAA are the size of buses and weigh 20 tons or 15 tons. So that's not a problem. I can't remember if that's the XB1 transmitter. It's a giant floating platform, but I got some great pictures of it. And anyhow, it's very possible that device, that platform is supplementing the weather controller's efforts. And so so anyway, we got the surface map here. You can see that storm that moved through Kentucky and those 5 states is still a closed low pressure at the surface level here at the 500 millibar. You see it right there. And you see these smooth isobars. This is really what the weather should always look like all the time. At the surface level all the way up to the 300 millibar level. There's that closed low right there. So there it is. There it is. Here's the surface map for the East Pacific. We've got cold front moving down and a storm pointing to the south. We'll see what happens there. 968 millibar. That's producing some very large swells. Let's see if we can get that right here. We can see that 35 feet in the center, and Hawaii's down here. Eventually, the Hawaiian Islands, the north shore of the Hawaiian Islands, as this system moves to the south, is going to produce some pretty big surf for the islands and everything that's facing the north. So right here we have that storm, and we got the islands down right here. This is moving south. Okay, so that's the report. I hope we covered that material well enough for you. Basically, once again, the weather controller is allowed this tropical moisture, which they never do. Most of the year they've got that guard band, I call it, right here, this which runs all the way across. Let's go ahead and zoom it back. This thing runs all the way across, and they maintain that separation for the very reason that we're seeing today. It has to prevent these severe thunderstorms. Okay. All right, so that's it, and we'll get another update here soon.